All right, let's talk about CAD-CAM Dentistry. So let's dig a little deeper and kind of figure some of this out, okay? First thing I want to start with is this idea that when it comes to digital technology in dentistry today, there's a myriad of options. Sort of the originator of a lot of this workflow or technology is the CEREC system. That's made by this company called Sirona. But just as a broader kind of, I want you to understand that there's many other companies that have very similar or the same workflows and technology as sort of the CEREC system. So what we're taking is just one specific company that we've bought their equipment to help train you guys with this idea of CAD-CAM technology. And CEREC's probably the most synonymous with CAD-CAM because it was the first, right? So at our school, we actually have two systems. We have the CEREC system, and then also this other company called 3Shape. And they make a Trios intraoral scanner. And then we also have all their design software as well. But the idea is, once you know one system, what we're trying to teach you is the principles of digital design and the principles of sort of scanning and the limitations and the advantages and disadvantages of that. So once you know one, the idea is that you can apply those same principles to any other system that you would come across in the future. So we are going to stick with the CEREC system because that's kind of what we started with, and that's what we have in our clinic, and they've been good to us in terms of donating a bunch of equipment. So CEREC actually stands for Chairside Economical Restoration of Aesthetic Ceramics. And this was a bit of a game changer in the sense that just like the video we showed, this is sort of the first introduction into a system in which you can get a crown made in the same day. So prior, remember all the steps that we went through to make a crown, a PFM crown? Think about everything that goes into that from the time that you make your impression. So you got to pour it up, you got to Pindex it, you got to mount it, then you got to wax it up, then you got to invest it, cast it, and then stack all your porcelain. So that it's pretty labor intensive. So with the advent of a lot of this technology, they're able to automate a lot of this stuff and use a different method of fabricating a crown. And with that came a difference in materials as well, which we'll talk about. So with the advent of higher strength ceramics, we're able to ditch sort of the metal coping PFM idea and have something that's all ceramic. All right, so let's just talk a little bit about the differences between the analog versus the digital approach. So you guys have all scanned digitally now with using our prep check software. So with the conventional method, obviously you got to wait for this PVS to set up, right? It's sort of a 5-minute procedure that you're waiting for this PVS to polymerize. Okay? So that was the conventional method of this elastomeric impression material. And we know there's some dimensional change when you make that. So usually pretty minor, but still some change. So now with digital imaging, where we just snap photos, the advantage of that is, well, you have the ability to re-image defects. So remember, as you're scanning your preps, if you get a bad image, you're easily able to just delete that and then go back and re-image. And the same applies if you need to modify your preparation. So if you need to slightly modify your prep because you've now blown it up and see that your margin isn't smooth or maybe you're under-reduce, well, you can very quickly cut out those images that contain the prep and then just rescan it after you've modified it. And all the other images around it, surrounding it, are still kept in place. Okay, so like your adjacent teeth, you don't have to rescan per se, but you can just rescan the areas that you've modified, which is a pretty big advantage in the sense that if you did that the analog way, think about this, you have to wait another 5 minutes for this new impression to set up. Okay, so there's sort of a time savings there if you ever need a reimage. So patient comfort, obviously you don't have that patient dealing with a bunch of gunk and goop in their mouth. Instead, you got to wave this little camera. Distortion. So with PVS, you get minor dimensional change, where your scanning technologies now are just as accurate as our conventional PVS methods. So there's no real loss in accuracy of a digital scan. And then cost and time savings, I put a star in there because there's still a learning curve in using this digital scanner. So in the beginning, I imagine that you're not going to save a ton of time, or any time at all. But once you've kind of practiced and make this part routine in your practice, this is probably a faster method than making a conventional impression. Okay? So it's maybe savings that you kind of see down the road. So one other thought about this impression, it's the principles of good impression making, whether it's digital or analog, is still the same. So you still need a nice clean margin. You also still need a well-retracted or a well-isolated field. So if you can't see the margin clearly after you've pulled your cord, it doesn't matter whether you're making a digital or conventional impression, you're not going to get a good outcome. Okay? So it's not like the digital method makes up for anything. It's just a different method to get you there. Okay? So it's not a magic wand that you're able to just wave in there and all of a sudden, oh, I don't have to worry about heme control or pushing the tissue out of the way. All those principles still apply. Right? It's just a different method of capturing it. So if you didn't pack enough cord, or your cord was too small, or there was some fluid there, you're not going to get a good digital impression either. All right, so once we've captured our impression, then our die trimming step, the analog way is to physically remove the stone around it with a burr, and you guys all experienced that last week. So in the digital method, you guys have all done this before, it's drawing the margin. And again, I want to reemphasize that point. Well, it's extremely easy to trim that margin or mark that margin when you got it well isolated, and you don't have to really think about, oh, is this the tissue or is that the tooth? You're able to just draw that line circumferentially, and then you know that you're good. Okay? So yeah, let's go through the advantages of this digital method. Is the ability to examine the prep immediately after the scan. So once you've scanned it, what you can do is you can blow it up real big. Right? And we have all these tools to analyze this prep. Well, if you were going to do that the analog method, guess what you have to do? You'd have to pour that up in stone, wait for that to set, and then look at it under a microscope. So you're probably not going to do that mid-preparation or mid-appointment. However, in this digital world, we have the ability to do so. Okay, so that's a pretty big advantage, is that you can analyze your preparations in real time. And over time, as you use the system, it actually makes you a better clinician, because you are constantly and in real time evaluating your own prep. Whereas prior, you'd have to wait until you got your impression, until it's poured. And a lot of times, you don't even go back to the lab to look at what you've prepped. It's only after the crown is made. All right, so you can evaluate the prep at a high magnification, and then you don't have to deal with stone in that Pindex system. And then the analog method, we would put a physical die spacer to make up for the room for cement. Here, we can just click some buttons, and we can virtually put a die spacer. So all the things that you can kind of do in the analog method, there's a digital approach to it as well. Okay? All right, and then the wax up. So the conventional method is to wax up your crown by just adding wax incrementally. In this case, with the software, and it'll run through some algorithms to get you a crown proposal that you can then modify. So what we're going to do today is teach you some of those principles and show you what each of those little tools do. Okay, so you can kind of raise cuss tips, lower them, scale it, bigger or smaller, And then you have these little wax tools that simulate what a waxing instrument would do. To either add wax or you can carve away. Okay. So let's talk about this wax step. So we got the ability to examine the prep and the margin immediately after the scan. So these are pretty similar kind of advantages that we have. I will note this about the digital wax up. So in comparing it to the analog method, with your crown on a physical articulator, you're able to not only close the teeth together, but you could also slide it side to side, right, and mimic those mandibular movements. So with the newest updates in a lot of these software systems in this CAD-CAM technique, you can simulate. It allows you to put it on a virtual articulator and then move the lower jaw in all directions. But there's not a great way right now to getting that face bow measurement. So remember, the face bow measurement orients your maxillary cast in accordance to that hinge axis. So the way they do it in this software is they just arbitrarily put that maxillary cast really just in the middle of the articulator. Okay? So it's an arbitrary face bow position, whereas in your analog method, you can make a customized measurement there using our face bow record. So there are companies trying to simulate and sort of come up with a digital approach to a virtual face bow. But I don't think it's there yet. But you do have the advantage of using a digital or a virtual articulator that you can still move. All right, you guys with me? Okay, so wax ups. Yeah, so we'll show you how to do some digital wax ups and show you some of the tools that we have in our system. Yes. All right, and then the last kind of difference that we'll see here is the actual fabrication method here. So instead of going through all the steps of the investment and then casting and stacking on porcelain, we're able to mill this restoration. So if you look at the top there, that's an Emax block. So remember from last week, Emax is lithium disilicate. It's a high-strength ceramic. And in the block state, it comes in, it's a purple color. So it doesn't turn that white color until we put it through a crystallization cycle. Okay? And the reason for that is, in the purple state, it's a bit softer because it's not crystallized yet, and it's a little faster to mill out the crown. So you can get the shape that you want, and then after you got the shape that you want, then you can crystallize it to make it strong. Okay? But essentially, it takes these two burrs that you see in the bottom, and is going to mill out or grind this block into the shape of the crown that you want. Okay. So all the investment casting / pressing procedures is replaced with this subtractive technique called milling. So a block of ceramic is reduced to shape with burrs under copious variation. Right? So let's talk about Emax real quick, just so we can clarify this point. Last week, I think Dr. Elgini talked about pressed ceramics, right? And one of the options for a pressed ceramic is Emax. So we're talking about the same type of material here. It's still lithium disilicate. So the point here is that Emax can be produced in two different methods. It can be milled or it can be pressed. So remember how this pressing procedure works? Somebody describe, yeah, why don't you describe how pressing works?
So it looks kind of almost like a little kiln.
So a very similar method to casting, right? So you still start with a wax pattern, you still invest it, but instead of slinging a bunch of molten metal into it, what you've done is you've melted this ingot of ceramic, and then you press that into the shape or the void that's created in the investment material. Okay? So with Emax, you can get an ingot of Emax, kind of melt that down, think about it that way, and then press it into place. Yes?
You don't need a sprue then, right?
No, you still need to do a sprue, yeah, because you still need a channel for that to go through. Yeah. So think of pressing almost like casting a metal restoration. So that's still, you still require a stone cast. You still require a wax up. So all those steps are still the same. And then the milling of Emax, you start with a Emax block in the uncrystallized state that you then subtractively mill and then fire to get the strength back. All right? So there's, plenty of other materials that kind of fall in that category too that you can either press or mill. So Empress is another type of material that you're able to do. And they also make feldspathic porcelain, just blocks of that you can mill. Right? So here's a slide just to show you just the number of options that we got. And there's just a ton of them from different manufacturers as to what type of materials that you can mill. So there's a myriad of material choices to select from. Understanding the material science is critical in order to select the appropriate block for that particular clinical situation. So at our school here, we're going to use basically two things that you'll be able to mill at our school. One is Emax. The other is TelioCAD, which is a block of PMMA. Okay, so that's in our acrylic. So we have a few of these other ones floating around, but for your purpose of your clinical experience, those are probably the two that you're going to be milling them out of. Okay? So the PMMA, we use those for long-term provisionals. So instead of using our bis acryl material, we're going to use our PMMA. So remember the disadvantages of our acrylic materials was that it's exothermic, it shrinks, right? So it's harder to use in the mouth because it's going to heat up and kind of disturb the pulp. Well, if you can mill it, what you have is a pre-polymerized block of it already, and all you got to do is grind it into shape. So all those disadvantages of shrinkage and exothermic reaction are kind of negated from this milling method, right? So yeah, you can see all the different types of material that are available out on the market, and this is just a sample of it. So you got feldspathic porcelain, you got translucent zirconium oxide, more feldspathic. There's lucite reinforced porcelain, which is our Empress, lithium disilicate, PMMA, zirconia reinforced by lithium disilicate. So all these different types of things that we can mill them out of. Okay, so let's talk a little bit about the burrs. So, because this is going to affect the way that we prepare the tooth. So before knowing exactly what the preparation guidelines are for, we must understand how the milling instrument works. Okay, so there's limitations to what we can mill. So we have what they call a step burr 10, and they come in different, you can get differing burrs of different lengths. But the idea is there's a pointed tip burr, and then there's a sort of square tip. Okay, so the step burr 10, that's for milling the internal surface of the restoration. So mills a fitting surface, or you can think about that as the internal aspect. And then your cylindrical pointed burr, that mills the occlusal surface. So you need a little bit of a finer point to get to get some of the more detail of the occlusal surface. Okay, so two different type of burrs that mill the different parts of it. So how does that affect our parameters? Well, you're limited by the height of the crown that you can mill, so the distance shouldn't exceed the length of that burr. Okay, so in this particular case, the step 10 burr is 10.5 millimeters, and they also have a step 12 burr, which I think is a little bit longer. Okay, so that's one consideration. The other is you got to think about the preparation and the thickness or the width of that burr that mills the internal aspect. So that burr width is about 1 millimeter wide. So that means it's not going to be able to mill anything that's less than 1 millimeter wide. So, for example, in your anterior tooth, if you had the point of your incisal edge come up to a real narrow point, well, the burr isn't going to be able to recreate that same shape because the burr is wider than what you're trying to mill. So one of the principles, or one of the ways that we're going to modify, really the only thing that we're going to modify in your preparations, is to round out any of those points so that we get a smooth flowing kind of transition that is sort of a wider curvature to it so that the burr can sneak in there and then mill that shape. So we don't want any line angles coming to a narrow cross section. So generally it's not as big of a deal in the posterior area, although you do have to look at your cusp tips, right? So our premolar number 12, look at your buccal and lingual cusp tips and make sure that those don't come to any sharp points. So think about the burr and the geometry there. You're going to want to make sure that that burr can sneak in there. Okay? So we'll show some examples of this. So we start off with the prep that comes to a pretty sharp point, and then you can see where the software in the milling machine has to over mill that restoration in order to kind of get to that point. So if you look at the screen right now, you can see how the burr would move in order to create room for that sharp tip. Okay, so let's back it up. Right, so the width of the burr is sort of your limiting factor. So this creates space between the restoration and the tooth. Right, so over-milling results in decreased retention / resistance form due to decreased adaptation to the preparation. So look at how that top area, see how much more space there is compared to the rest of the preparation, or it's more tightly adapted to a prep. So that can influence your retention resistance form, or how well that crown stays on. So we want to minimize that gap that we have in these CAD restorations. So I would say this is one of the main disadvantages of a CAD or computer-aided, or CAM, sorry, computer-aided manufacturing crown, is the fact that these crowns are generally much less adapted to the preparation compared to your traditional method. So some of you guys got your wax patterns back, right? Those wax patterns were actually milled. And when you put them back on the die, did some of you guys experience there's a little bit of that wiggle room from that wax pattern onto the die, right? So some of you guys felt that. The idea there is that that's sort of a minimally acceptable level at which that crown would fit. If you did the wax pattern or even a pressed ceramic the traditional way, where you press it or cast it, those crowns are much better adapted to that preparation. So when you put, let's say, just a gold crown that's been casted onto your die or your tooth, you get much less of that wiggle room there. Okay? So there's a difference in the adaptation between a milled restoration versus a casted / prepped. So I would write that down in your notes somewhere. Okay? And the principle is because of just the way it's manufactured. The milling will overcompensate for certain areas. Okay? Right. So here to the dotted red line, you can see that the way that we need to modify that prep. So your incisal edge height is actually going to be a little shorter after you have modified that. And that's okay for the sake of our exercise. If you're doing this from the beginning, you'd kind of want to account for this when you do your reduction. Okay? But you want to round that out so you can imagine your 1 millimeter wide burr. You have to ask yourself, can I sneak into that area and minimize the amount of over-milling? So actually, when you go and start to do your design, select your slice tool and get to this viewpoint, this orientation. And you can analyze in your own design how your prep would affect the over-milling. Okay, so you kind of want to see for yourself after you've modified how much space you have there. We're trying to minimize that space. Okay. All right, a couple other principles. This is a different application. We're going to learn about inlays and onlays when you guys get back after you do operative 2 and endo. So this will come in mid-October. But I want to show this principle here. And very similar in the sense that if you have any sharp transitions, again, your burr isn't going to mill that sharp angle there. So for your preps, you have to reduce more in certain situations. So that may be another disadvantage of your CAD-CAM system, is that you have to modify your preps, and you may have to be more aggressive in certain areas just because your method of fabrication is limited. Okay? All right, let's talk about the margins. So here we can see a spike in the margin. And again, we don't have a burr that's going to mill this accurately. So what the software does is, so the first picture in that middle section is our proposed margin. That's what it scanned, and that's what it wants to do. What the software is designed to do is actually to undermill it. Okay, so this is the opposite of the internal surface. So the internal surface, it'll overmill. On the margin, it'll undermill it. Okay. So if you don't have a nice smooth margin, you're going to have a result that's like this. Okay. It's going to have an open margin because that area that was scanned, where that crown is made, it was undermilled, and therefore it's going to touch that margin, that tooth there first, and leave everything else open. Okay. So somebody had said earlier, oh, what's a disadvantage of the CAD-CAM restoration? One is the technique sensitivity. You're not able to get away with as much in this CAD-CAM crown in terms of marginal smoothness, right? Even a little discrepancy like that would throw it off. Whereas if you contrast that with a pressed Emax, right, you're still waxing up to that contour and pressing to it. So a press restoration will be able to fit to that little discrepancy. So anything pressed or casted is going to be much more forgiving in that sense. Right? Does that make sense? All right, let's talk about undercuts. So you can see on the facial surface towards the margin, we have a pretty big undercut right there. So the analog method, we would physically block that out with some sort of acrylic. Well, here we can do a digital block out. So let's think about the disadvantage of having an undercut. Well, one, in the analog method, it was the fact that we can never get our wax pattern to come off. Well, we've avoided the wax pattern in this situation. So the disadvantage here is your material thickness. Look at the thickness of your material towards the margin there. It's much thinner. So what comes with that is a potential decrease in the strength of the restoration, because your ceramic thickness is thinner. Or two, in order to get the proper thickness, you may end up over-contouring the crown, right, and make it bulked out. Let me quickly step back to this idea that if your ceramic is thinner, you may have some sort of kind of aesthetic compromise because the underlying tooth structure is going to show through some more. So remember Dr. Algini talked about getting the stump shade, what the color of the tooth is underlying it. Well, that color is going to shine through a lot more the thinner that your crown gets. Okay? So that's that principle. It's either going to be over-contoured to make up for the thinness, or you're going to have some sort of strength or aesthetic compromise. Oh, so notice the top here. Remember we talked about recontouring your prep so that it's better adapted. So look how this here, the burr is able to sneak into this area because they've avoided a sharp point in their preparation. So this is similar to what you want to see when you prep. All right? So just a few, this is straight from the Ivoclar handbook when it comes to prep guidelines. So just want to show you their recommendations for the amount of incisal reduction as well as your shoulder margin. Okay, so they want a minimum of 1.5. We've taught you guys 2, which is okay. We've given you a little bit more room here, and still the same, millimeter shoulder. And then for our posterior crown, this is essentially what we had given you. This is the 1.5 millimeter occlusal reduction, and then a 1 millimeter on each side shoulder margin. Okay, so that's the reduction parameters for our Emax crowns. Let me just run through real quick. These are actually some of our own cases that we submitted for our wax patterns. But I want to show you some of the errors that we see in this acquisition phase. Okay. Sometimes if the images aren't stitched well together, or if you have a bad image, it's going to result in one of these pinhole defects. So be certain to spin your restoration around and kind of evaluate to see that you have this well captured and that you got a smooth axial wall surface. Okay. We also get some submissions that just have bad data. This obviously isn't the contour that your prep was. Okay, so make sure to look around and see that it looks like a tooth prep or a crown prep. Okay, so these things should be obvious to us and should be able to, we should be able to detect these kind of right away. Okay. Another thing that we saw, not a lot, but a few students didn't prep their margin. They left it too supragingival, meaning the distance between the teeth was minimal. So we wanted at least a 0.5 millimeter separation between your teeth near this contact area. So one of the reasons for that, think about the analog method of making a crown. What did we have to do once we got the casts poured up and Pindexed? We had to trim the die, and before we can trim the die and remove the die, we had to suction that prep. So they take, remember the video, they took a little blade and they went in between the teeth and started to saw it. So when you guys got your cast back, you guys noticed that that was already separated because somebody had sawed the die off. Well, if you don't have room there for that saw to fit through, you're not going to be able to do that accurately. So that's the critical part about having enough separation in the analog method. In the digital method, that principle still applies because instead of a saw fitting through there, you got to have light that's going to hit that tooth and bounce back up. So if you don't have enough separation there, it's going to have a real hard time distinguishing where your margin is because all that area is obscured because there's not enough space between the two teeth here. Okay. So again, just to reemphasize the point that yes, it's a different method to get our impression, but your principles of either tissue retraction or prep design is very similar. All right, so just other images of bad data. It's important to keep, for our purposes, our margins supragingival so we can mark it clearly. Obviously, clinically, you're going to work with your clinical faculty to determine what the margin, the most appropriate margin placement is going to be. But just know if you're equa or subgingival, it's going to require a little bit more work because you still need to get tissue retraction, right? So those principles still apply. So sometimes we get shadowing. So this could be probably because of the angulation that we took it at. Sometimes that the interproximal contacts will cover or cast a shadow around that margin, so it's hard to read. So here's another example of it. So when you take your initial photo of your prep, you want to come straight above and that you want to see space, just like you see here, between the margin and the interproximal contact. If you have it leaning, that's going to be an issue. Okay, it's another example of that. So you want to see this is the outcome that you want to see. Okay, so this obvious example of just bad data. So either more images or I don't know what went on there. All right, design. So once you got it scanned, Dr. Yates is going to go through all the different tools that we have to design. So I'm not going to spend a bunch of time on this, but the idea is that one of the differences, you're going to get the scan of the opposing arch of your tooth, because of course you need to know how high or how tall to make this. And then you want to take a look at your cusp tips. You want those to line up. Your central grooves should line up. I think one of the main errors we see in design is your marginal ridges should be at the relatively the same height as the adjacent tooth. So all those principles that you had learned in your operative class with composites still apply here too, right? So when you make your class 2 restoration, whether it's amalgam or composite, one of your guidelines is, okay, let's make those marginal ridges similar. And then you want the height of contour, you want to mimic those on the adjacent teeth. Okay. All right, and then the last part is once we got it milled, we're going to crystallize this, and then we're going to do a little staining and glazing. So once you crystallize this crown, this color comes out just a monochromatic color, just one color. The fact that we got this little bit of cervical staining and a little incisal translucency is due to our staining of it.